All right, let's get started here. Just to make sure, can you guys hear me? You can type in the chat. There we go. All right, excellent. So the way this is going to work today, I'm going to go through the assignment with you. However, when I open up the assignment and share my screen, I cannot see any of you or the chat or anything. So what I suggest is if I'm going through something too fast, or if there's something that you see that doesn't make sense to you, you need to ask a question. You need to turn on your sound and you can just tell me to stop, okay? Or tell me to slow down or tell me that you have a question, because I won't be able to see you. I won't be able to see the chat or anything like that. All right, so thanks for joining here today, the first kind of live virtual day. So let me share my screen. All right, so I'm going to show you how to get here. If you haven't yet, you can open up your Canvas. You might have to, well, you probably got, since you're here, you opened up your Canvas, but you might have to make a second tab. And week 14, or to use this link to get to the Google Meet, I'm going to go to Monday, Tuesday. So the stuff that we go through today, if you get it done, then you don't have anything to do tomorrow. And then Wednesday, there will be an assignment. And then Thursday, for you guys, again, at 8 o'clock on Thursday, I'm going to have you sign in and we'll do this one together. So let's start with this. All right, so first we're going to go to this, this link here. It's a simulation. I can click on the play button. And this is the simulation that we'll be working with. So I'm going to open up this net charge. This was in this mass number. I'm going to open up those things so I just have a little bit more information that I can see. All right, we're going to be talking about atoms. All right, and as we can see up here, we have these are all the elements, all the different types of atoms, and that's the periodic table of elements, has all the different types of atoms in there. All right, back to the assignment. Whoopsies. Here's the assignment. We're going to use a periodic table at times. If you want to open this up and just keep it on a tab, you can. We're not going to use that right away. And then you're going to click on this down here. All right, and this is going to open up this assignment. And I will kind of split screen this a little bit so you can see both things. All right, so first, okay, we went to the simulation already, so we don't need to click on this. I should go through the goal. The goal of this is to build atoms, and we're going to better understand the properties of the subatomic particles. And the subatomic particles are the things that make up an atom. So if you're not familiar, there are three things here: protons, neutrons, and electrons that help help create or help build an atom, and in different ratios and different amounts and different things. We're going to see how they affect the type of atom that we're building. All right, so question 1: build 3 different neutral and stable atoms by adding different subatomic particles, protons, neutrons, or electrons. 1 should be hydrogen, 1 should be helium, and 1 should be lithium. Take screenshots and insert them into the boxes. Resize them to enough to fit questions 1 through 3 on the first page. Okay, so first I need to build a neutral atom. Okay, so I'm just going to start with the proton here, and we see some things that change. Okay, so this is hydrogen. That is what we need to build. Okay, so I need to make sure that it stays hydrogen. All right, so now let me add another proton. Nope. Okay, now it's not hydrogen anymore, it's helium, so I'm going to take that one away. Good, it goes back to hydrogen. Let me add some neutrons. Okay, this doesn't really seem to be changing a whole lot, except here this mass number, if you see, the mass number keeps changing. Okay, I'll just keep it at this. Oh, I should click on, I forgot to mention this stable and unstable option down here. Oh, it's unstable. It doesn't say anything about that yet. Okay, now I need a neutral atom, and we see then the net charge is +1. Neutral would be 0. So I'm going to add an electron. All right, it says right here neutral atom. So this is what we need here. Okay, now I'm going to take a screenshot. To do that, I hit Control Shift, and then the button above your 6 on your Chromebook, it's like a box with 2 lines after it. I can draw a box and it'll screenshot this down here. And then I can copy it to clipboard. I can go over here. And then I can paste. Okay, so Control V for paste. All right, and then we have our neutral hydrogen atom. All right. Next, I need to make a neutral, right? Everything is neutral, yeah. Oh, I messed up. It said stable atom. I didn't make a stable atom. So let's see. If I add more electrons, oh, that keeps changing the charge. I don't need that. I want it neutral. I know if I change protons, it changes the type. I got to make it stable. I'll start. Oh. So I could do this, or I could do this. I'm going to do this one just because, I don't know, I'm just choosing to. So now I have to recapture, so Control Shift. And then that box with 2 lines after it. Start over here and Control V, paste it in. All right, there we go. That's a neutral, stable atom. All right, now helium. I remember when I put 1 proton in there. It was helium, so I need a helium atom. This is stable, so that's good, but it's not neutral. Now it has a +1 charge again. So to make it neutral, I'm going to have to, oh, I can add more electrons. So these electrons make these blue minus signs here. The protons make the red positive signs here. And so as long as I have the same amount of both, I have a neutral atom. So again, this one satisfies everything. So Control Shift, box with 2 lines, copy, Control V, and I got that one. Now lithium. Okay, well, I remember I added a proton last time to change this name, so I'm going to do that again. Okay, I got lithium, good. But now I have these 3 pluses. Well, I want it neutral, so I have to add an electron. Well, it keeps pushing it out to the second ring, but I guess that's okay. It's neutral, but it's unstable. Let me take this away. It's still unstable. Let me keep adding them until we get to something that's stable. There we go. Control Shift. Copy. Control V. I can paste that in. Okay, underneath, which subatomic particle changes the type of element of the atom? The type of element. Oh, so the name. So which subatomic particle changed the name? That was the proton. The proton changes the name. So if I ever add a proton, it just keeps changing the name to something else. All right, question 2. Let's go to question. Build different ions of the same element. Okay, so build lithium. Okay, I have lithium as a neutral atom. Okay, I got that. A plus ion, so it says a +1 net charge, and a negative ion, which is a -2 net charge. So here's the net charge. Let me add some neutrons here. that changes the stability and the instability, I guess you could say. All right, here it says neutral. If I add electrons to it, oh, it says minus ion there. Let me maybe add a proton here. That doesn't, it's not lithium anymore. So I guess, oh, maybe I could take these away. Whoa, did you see that? That one just migrated to that inner circle. All right. Well, now it's a plus ion. Okay, so neutral. Well, I already had one that was neutral. I'm going to copy that one. So you can copy, which is Control C. And then I'm going to paste it here. I already got that neutral one. Okay, a plus ion. I have that plus one net charge. Okay, I've got that. So now I can take a screenshot of this. Copy, Control V. And then a -2. Okay, so I gotta keep adding electrons here. And here it's still a negative ion, but we need to check the net charge over here. It's at -2 right now. So this is what we want. So Control Shift, copy. Okay, so we have that. All right, good. Okay, which subatomic particle, proton, neutron, or electron affects the charge and changes an atom into an ion? Okay, so this was a little tricky because if I add protons here, that can also change the charge, but it changes the name. We really focused on changing the electrons here. Electrons are really kind of responsible for changing the charge of a single type of atom. If I change the protons, I can change the charge, but I'm also totally changing the type of, or the name of the atom. It's a totally different type. Electrons keep the same type, lithium, 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 but it changes the charge from neutral to +1 to a -2, or we could really create any charge if we keep changing the amount of the electrons. All right. Build a stable and unstable atom of the same element B. They should both be neutral. Take a screenshot. Okay, B. Well, it says lithium. Oh, if I look up here on this periodic table, it says HELIBEB. So I want to get to this one here. So I know if I add these protons that it changes the name. I remember helium and hydrogen were in there. So I'm just going to keep going up, and you can see every time I add one, that highlighted box just moves to the right one. So this is B. All right, so this is boron. We need a stable and an unstable atom. They should both be neutral. Okay, so, oh, this is neutral. All right, so that's good. This is unstable, so I can take a screenshot of this. And I'll put it in the unstable box. I'm going to shrink this a little bit. And then stable, I got to make this stable somehow. So really, these neutrons are what's affecting if it's stable or unstable. So I could do this one, or I could do this one. Both are stable. I'll just do this one here. And I'll take a screenshot of this. I'm going to shrink this down a little bit just to make sure everything fits. Okay, and what subatomic particle is responsible for this? It's the neutron. All right, click on the symbol on the screen, the bottom of the simulation. So that's all the way down here, symbol. Excuse me. All right, we are going to, let me maybe shrink this just a little bit more, make this a little bit bigger. Okay, we get this symbol over here where we have 3 kind of boxes. All right, looks like I'm running low on power here. All right, played around with the simulation to label the parts. of an isotope symbol. Okay, so this is the isotope symbol here. What does the box A represent? So A is this upper left. Oh, let me turn this on. So this A in the upper left, that changes anytime I add a proton or a neutron. Yes, Kaden.
So did you know I'm actually at a new level now?
I didn't know that. Okay. No, I can't right now. I'm teaching. I'll come look at it later.
Spaceship went away. Now there's another door open.
That's really cool. All right. I'll come check after my class, okay? Sorry about that. All right, so let's keep going here. So A, every time I add a proton or a neutron, this changes. And you can see this symbol here. All right. When I go back over here, it's the same symbol here. That's called the mass number. All right, so what does A represent? That's the mass number, which is equal to, this is 11. Let's see, this is 8. Where does 8 come from? Every time I add a neutron or a proton, it changes. And so the mass number is equal to the protons plus the neutrons, both of them. All right, so what is it? Oh, let me put a space in there. What does it represent? The mass number. And then how do we find it? We find it by adding the protons and the neutrons together. Okay, what does Z represent? That's down here. Okay, let's, if I add these, this changes the mass number, but it's not changing this at all. This is changing the charge, but it's not affecting this at all. This would be the protons. Okay, so Z, what does that represent? The protons here. Now let's go back here. Let's see. We know that it changes the atomic number, or I should say, I just kind of gave it away. All right, we know that it changes the type of the atom. And I think what we were asking you to maybe do is use this periodic table that we opened up earlier. And if I choose something, what are we on? Carbon. Let me click on carbon. Oops. Oh, is it not working? Come on. I believe if I click, double click, usually it pops up with a little bit more information. Let's go properties. Here it is over to the left. Let's see. Nope, not that one. Did it pop over to the left and I clicked before? No. All right. I'll help you out on this one. I kind of gave it away already. It is called the atomic number. The atomic number is the same as the protons. So if your atomic number is 5, you got 5 protons. If it's 6, you got 6 protons. They're always the same. But the atomic number is how we order these things, which is also the protons, the amount of protons. That's how we order these things. All right, C, what does C represent? So that's the upper right-hand corner. Okay, so this says +2. That's a positive ion. So plus, and you can see it has that symbol next to it, which is the net charge. So that's the net charge. How do you find it? Using subatomic particles. So here, this is, there's a couple different ways, but mathematically, I think it's easiest to take the protons and subtract the electrons. It's really, which one do you have more? If you have a negative, and I'll go through this with the video for Wednesday with the notes, but if you have a negative, I should say, you can count all your negatives and you can count all your positives. If they're the same, it's going to be a neutral charge. If you have more negatives, it'll be a negative charge. How negative? Because it could be negative 1, 2, 3, 4. It'll be as negative as however many more electrons you have. So if you have 2 more electrons, it's negative 2. And the opposite is true for positive. If it's a positive charge, then we have however many more positives we have, or protons. All right, that's the charge for it. All right. So that link is if you aren't here, but you are all here. Design a positive ion with a charge of +2 and put it in a screenshot, resize to keep the assignments 2 pages max. Okay, a positive ion with a charge of +2. This one's got +1. So I'm going to make that +2. It doesn't say anything about stable. It doesn't say anything about which type. So I'm just going to keep it like this. Screenshot that again. And I'm going to paste that in. I'm going to shrink that a little bit. Okay. Design a neutral atom with a mass of 8. Okay, so this is 13. So I got to definitely make this smaller. Oh, took away a neutron. That's okay. Just want to take away these protons here. Okay, so mass number 8. Neutral atom. Okay, I can see I have 2 more negatives there. So I'm going to try to take away these negatives. Okay, so now it's neutral. Resizing. Okay, we're good. Didn't say anything about stable or unstable. I'll paste that in and I'll shrink that a little bit. Whoop. So when I shrank it a little bit, it just went up there. That's okay. I'm going to delete this extra space. Okay, that's good enough. All right. Complete the 4 levels of the game in the simulation with 4 stars or better. Insert a screenshot of 4+ stars on the 4 levels. So down here, if you click on games, all right, we have these games here that you can use. You need to complete 4 levels. So each level, okay, this one will be easiest. This one will be a little bit harder, and this is the hardest here. You need to get 4 stars or better, okay? Insert a screenshot of, so once you're done, so if I do this, it'll show me how many stars I get. So at the very end, you can take one screenshot of all of these, or if you're not going to do it all in one sitting, which I think you guys could all do it right now. But if you're struggling with it, make sure you take a screenshot of maybe levels 1 and 2 or whatever you get done. And then if you come back later, you can add a second screenshot of the other levels. Okay. You can use a periodic table to help you with these. I think a periodic table shows up when you play the game. But I'm going to let you guys, I'm going to give you guys the rest of the time here. We got 6 minutes to complete that. So let me come back here. All right, so I'll just double check with you guys now. I need some form of communication. Any questions, or how did that go? Are you guys following along? Let me check the chat. I got nothing in the chat. So either put in the chat or turn your microphone on and let me know that you are still there. Hello.
I'm still there.
There we go. All right. Thank you. Got some in the chat. Oh, yes. Excellent. All right. Sweet. Awesome. All right. Any questions before I give you guys more time to work? That was a silly. Maybe here's what I'll do. Put in the chat. 5 being you are ready to crush those atom quizzes. 1 being you're like, what's an atom? Okay. Put in the chat where you're at right now. All that rhyme. Put in the chat where you're at, 1 through 5. How you feeling? Oh yeah, look at that. All right, good. I'll give you guys time. If you guys run into issues or have questions, send me an email. We'll be going through this the same thing all day at 9 o'clock, 10 o'clock, and then at 11 also. And I know you guys have other classes too, but if you run into issues, make sure you send Miss A or I an email. I am running out of battery power here, so I might just go out here any second. Okay, but good work. Keep working. Make sure that you submit those things today in order to get counted for attendance. Miss A, anything to add?
Not off the top of my head.
All right. Good luck. I'll stay on for as long as my computer will stay alive, and then you guys will have to jump on to your third period class at 9 o'clock.